Welcome to the lesson on the conversion of solids from one shape to another. At the end of this lesson, you will be able to set up an appropriate equation which will lead to a solution for problems on the conversion of solids. You will also apply your knowledge to solve selected problems. When we cut a watermelon into slices, we are converting a solid shape into other solid shapes. Regardless of the size and shape of the slices, there is one fact that holds true of the whole process. The volume of all the slices together exactly equals the volume of the original watermelon. When we convert a solid of a given shape to a solid of another shape, the surface area usually changes. However, the volume is preserved. This is the basic principle that is at the heart of any problem in the conversion of solids from one shape to another. The volume of material that we start with and the volume that we end with remain the same. In many cases, a single solid item is converted to a number of items, and we are asked to compute the number of such items that can be produced. In other cases, we are given the available number of items of a converted solid. We are asked to compute the height, radius, or some other dimension of the converted solid. Whenever a solid shape is converted to another shape, the volume of the object on the left always equals the total volume of the objects on the right. This equality can be expressed as the equation volume of one object equals n into volume of each shape of the second object. The quantity n is the number of objects on the right. In some problems that we will be asked to solve, we will be provided with the shape and dimensions of both objects. We will be asked to determine the value of n. For the example on the screen, we convert a cuboid of dimensions 6 into 2 into 2 centimeters to a number of cubes of side 2 centimeters. We are asked to find n, which is the number of cubes produced. We will equate the volumes to get 6 into 2 into 2 equals n into 2 cubed. We will then solve for n to get n equals 3. In some problems, n is provided, but the dimension of the object may not be. We have to determine the value of the missing dimension. For the example on the screen, we convert 8 into 2 into 2 centimeter cuboid to 4 equal cubes. We are asked to find L, which is the length of the side of the cubes produced. We will equate the volumes to get 8 into 2 into 2 equals 4 into L cubed. We will then solve for L to get L equals 2. Yet another type of problem that we may be asked to solve is if the shape of an object is changed. We have to determine the resulting surface area. For the example on the screen, we convert 3 equal cubes of side 2 centimeters to a 6 into 2 into 2 centimeter cuboid. We are asked to find the total surface area of the cuboid. When a solid changes shape, even though the volume remains the same, the change in geometry of the shape causes the surface area to change. We will use the standard formula to calculate the surface area for the resulting cuboid, which works out to 56 square centimeters. It is interesting to compare the areas for the initial and final shapes. The surface area for the 3 cubes is equal to 3 into 6 into L square, where L is the length of the side of a cube. This evaluates to 72 square centimeters. We have evaluated the surface area of the cuboid to be 56 square centimeters. As is evident, the areas are not equal.